Welcome back, ladies and gentlemen, to the second distance learning video on Calculus BC. In this episode, we will be covering a Maclaurin series example. We will be representing the function f of x equals sine x using a polynomial. And since this problem specifies a Maclaurin series, we will be centering our polynomial at x equals 0. Now, before we begin, I'd like you to take a second, hit the pause button, please, and go ahead and derive sine as many times as you can. I'm going to do about up to the fifth derivative. And then I want you guys to do the same thing for p of x. Just derive it up to the fifth derivative, and then we'll reconvene in a second. Let me go and pause real quick so that way I can speed this thing up a little bit. Okay, at this moment in time, you should hopefully have this as your association and your function and your polynomial. So we are ready to associate this thing. Now, I shortcutted this, and I already threw down the factorials where I needed to, and then and hopefully you guys are going to be able to do the same thing. And so from here, let's go ahead and just make some associations. We're going to do exactly what we did in the last video. We're at the Maclaurin series. We're going to center it at 0. So I'm going to say, well, f of 0 will equal p of 0. F prime of 0 will equal p prime of 0. F double prime of 0 will equal p double prime of 0. F triple prime, oops, that's not an F. F triple prime of 0 equals p triple prime of 0, and I'll go down the chain as we go. So from here, again, if you want to, you can hit the pause button if you want, but I'll go and just scroll up for a little bit here. If you notice, if I let f become 0 here, or f of x, if I let x become 0 here in f of x, sine of 0 is 0. And that's going to get me all of these guys to go away, so 0 equals a, no question there. F prime of 0, cosine of 0 is 1, and that's going to get me all of these guys going to 0 will get me b. F double prime of 0, sine of 0 will be 0, equaling, looks like I'm going to get on this side 2c equaling 0, so c basically equaling 0. Now, before you jump too far ahead and say, oh, I notice a pattern, it's going 0, 1, 0, 1, 0, 1. Unfortunately, the third derivative doesn't quite follow that pattern. The third derivative has us plugging in 0 into cosine, or negative cosine. So we get negative 1 equaling the p triple prime becoming 3 factorial d. Right? And again, remember, we're solving for a, b, c, and d here. So d actually equals negative 1 over 3 factorial. So please don't fall into a trap pattern of going, oh, yeah, it's 0, 1, 0, 1, 0, 1. This time it's not quite going to work out that way. And I'm going to go and do the fourth and fifth derivatives down there, down here. So if you have it on your paper, I'm hoping you do. P, fourth derivative, 0. 0 is going to be e. Now, the fact that each of the even terms is turning out to be 0 is a pattern. But f fifth derivative at 0 will be something else. In this case, the fifth derivative at 0 is going to become 1, and that's going to be equal to 5 factorial f, which then becomes f equaling 1 over 5 factorial. Now, after you've established the 1 and the negative 1 over 3 factorial and the positive 1 over 5 factorial, I think now a pattern can start being associated here. So p of x, we'll do it in a different color here, p of x, since that's our polynomial color. Remember, the basic polynomial equation is this guy. It's the a plus bx plus cx squared plus all that stuff. So from here, a was 0, in case you don't remember. A was 0, and that's going to be plus 1bx, so that's going to be plus 1x. C, I'm not going to worry about him. D is going to be minus 1 over 3 factorial, and attached to the d term was an x cubed. If you look back at your polynomial, right, attached to the d term is an x cubed. And then plus 0 here for e, and then it'll be plus a positive 1 over 5 factorial, and associated with f is an x to the fifth term, so x to the fifth. And I think from here we might be able to start establishing a pattern here. You might be able to start saying, okay, I think I know what the rest of this is going to become. The rest of this is going to become minus 1 over 7 factorial x to the 7th, plus 1 over 9 factorial x to the 9th, and down the chain we go. So it looks like we're doing every odd iteration here. So I'll go and just do this without the 0. X minus 1 over 3 factorial x cubed plus 1 over 5 factorial x to the 5th minus 1 over 7 factorial x to the 7th plus 1 over 9 factorial x to the 9th plus dot dot dot. Okay, let's go ahead and see what happens when I plug this thing into the Inspire. So here is our TI Inspire right here. Now what I'm going to do is I'm going to actually do something really, really odd. I'm going to enter in each piece of our series independently. So what I'm going to do is I'm going to say, all right, my F2 is going to be X. Very cool. Very, very bad, right? Very, very bad approximation. Except right in this little window right here. If I just leave him in this very little window right here, I'm going to go ahead and have a convergence where the red is on top of the blue. Well, from here, what happens if I do X minus 1 over 3 factorial, and I'll throw it out in x cubed. Notice the black function. The black function is more accurate than the red function. It goes down, and then it models it right here, comes back up. And I think you guys are going to start seeing what's going to happen here if I start adding more stuff onto here. So x minus 1 over 3 factorial x cubed plus 1 over 5 factorial x to the 5th. Look at the purple function. The purple function is modeling this thing better than the black function and much better than the red function. And I think you guys are going to start seeing what's going to happen. I'll go ahead and just jump straight for the final grand finale here. Minus 1 over 7 factorial x to the 7th plus 1 over 9 factorial x to the 9th. Notice the green function, how it models the function really, really, really well. So that is your example here for the for this problem here. And go and leave any comments or questions in the questions box. In the next episode, I'm going to do a shortcut for all of this. I know this is pretty laborsome work right here, and it's a shortcut. It's a shorter cut anyway. But yeah, I will see you in the next one.